Good morning, student. In the last classes, we are seeing the chapter Parabola. Okay, student, we have seen some concept about the parabola, and we have seen the different cases in which the parabola can be formed, and we have seen the vertex, focus, directrix in all the cases, and lattice rectum. Okay, student. Now today we will see some questions based on in different cases. Okay, student. Let's see. Our first question is, y square is equal to 4x plus 4y. Okay. We have to find the vertex, focus and directrix, lattice rectum, okay, of this parabola. Y square is equal to 4x. Y square is equal to 4x plus 4y. Okay, student. So first of all, student, we will make this part and we will change this in the form of its standard form. Okay, so we write this is 4x. Okay, student. Now this is y square minus 4y. We add plus 4 and here minus 4. So this we can write y minus 2 whole square, and this is 4x plus 4 student. This is y minus 2 whole square is equal to 4x plus 1. Okay, student. So this we can write in this form, student, and here this we can write, this is capital Y square is equal to 4 capital X, where capital Y is y minus 2, capital X is x plus 1. Okay, student. Now, student, we are seeing that what we have to find out when we are comparing this part with y square is equal to 4x, we are seeing that our 4 is equal to 4, so our a is equal to 1. Okay, student. Now, student, we have to find its vertex. So vertex is 0, 0. It means that x is equal to 0 and y is equal to 0. So x is x plus 1 equal to 0. So x is minus 1 and y is y minus 2 equal to 0. So y is equal to 2. So its vertex will be minus 1 and 2. Okay, student. So vertex is minus 1, 2. Now we second find its focus, student. So its focus, this is the first case. Okay. So in this case our focus is A0. Okay, student. Okay, student. So in this case our focus is A0. So our x is equal to A and y is equal to 0. So x is our what? Our x is x plus 1 and a is equal to 1, student. So we are seeing that x is equal to 0 and y is y minus 2, which is equal to 0. So y is 2. So focus is what? 0, 2. Okay, student. This is our vertex and this is our focus. Now we have to find out its directrix equation. So directrix is what, student? So in this case our directrix is x plus a is equal to 0, student. Okay, so x is, x is equal to x plus 1 and our a is 1, so this is 0, so this is equal to minus 2. Okay, student. So directrix is x is equal to minus 2. Now student, we are saying that we have to find the next is axis. So the here is x axis, so equation of axis is y is equal to 0, student, and our y is y minus 2 is 0, so y is equal to 2. Okay, student. So our axis is y is equal to 2 and lattice rectum is 4. Okay, student. So lattice rectum is 4 and this is equal to 4. So we can say that our lattice rectum will be what? 4. I hope you understand, students. Let's see once again. This is our question. Y square is 4x plus 4y. Okay, student. Now, and we have to find the focus. We have to find focus, vertex, directrix, axis of equation, and lattice, length of lattice rectum. Okay, so first of all, student, we make this part in the form of y square is equal to 4x. Okay, either we can say that in the form of a standard form. Okay, so we are first using the method of completing a square, adding plus 4, subtracting minus 4, and we are getting that y minus 2 whole square, which is equal to 4x plus 1. So this is y square is 4x, student. So y is y minus 2, x is x plus 1. So here we are, when we are comparing this part with 4a, so we are getting a is equal to 1. And here this is our capital Y and this is capital X. Okay, so y is y minus 2 and capital X is x plus 1. So vertex, so student, in this case our vertex is 0, 0. So our x will be equal to 0 and y will be equal to 0. This x is equal to x plus 1. This y is equal to y minus 2. So this is minus 1 comma 2. This will be our result, vertex. Now our focus is a0. So x is equal to a and y is equal to 0. So x plus 1 is equal to 1 because a is 1. So our x is, this will be cancelled, or x will be equal to 0. Now y is equal to 0. So y minus 2 is equal to what? Y is equal to 2. Okay. So our focus is 0, 2. And directrix is, equation of directrix is x plus a is 0. So x plus 1 is 0 because a value of x is x plus 1 and a is 1, so x is minus 2. And axis of equation, this is x-axis, so equation of x-axis is y is 0, so y minus 2 is 0, so y is equal to 2. Okay, student. Now our lattice rectum, so 4a is equal to 4, so our lattice rectum is 4. I hope you understand, students. Now we take another question. Let's see. question is, student, find the equation of parabola with vertex 2 minus 3 and focus is 0, 5. Okay, student. So this is our question, that find the equation of parabola whose vertex is 2 minus 3 and focus is 0, 5. Okay, student. So student, we are making a small parabola like this, where focus is 0, 5 and vertex A is given, which is 2 minus 3, and this is our directrix. Okay, student. And here is a point PXY, and this is M. Okay, student. So we know, student, we know that this vertex is the midpoint of this S and this directrix. Okay, student, we know that this vertex is the midpoint of this focus and directrix. So when we are supposing the coordinate of R is x1, y1. Okay, student. So we apply the formula of midpoint. So here we can write, student, our 2 is equal to x 1 plus 0 by 2. So x1 is 4 and 5 is equal to, and this is minus 3, which is equal to y1 plus 5 by 2. So y1 is minus 6 minus 5, so y1 is minus 11. So our coordinate of R is 4 minus 11. Okay, student. So our R is student, the coordinate of R is 4 minus 11. Okay, student. Now we have to find the equation of directrix, student. Okay. For find out the equation of parabola, first of all we will find the equation of this directrix. Okay. So for finding the equation of directrix, first we find the slope of this AS. So we write slope of AS what is x1 by 1, x2 by 2, 5 plus 3 by 0 minus 2. So this is minus 4, student. Now slope of MR will be equal to minus 1 by minus 4. So this is equal to 1 by 4. Okay, student. Slope. So student, slope of MR, which is perpendicular to this line, is 1 by 4. Okay, student. So slope of AS is this, slope of MR is, M2 is this, which is perpendicular to this line. Now, student, we are seeing that equation of MR passing through this point R, which is 4 minus 1, and having slope, and student, slope is 1 by 4. So equation will be y minus y1 is equal to m x minus x1. Okay. Now do cross multiplication 4y plus 44 is x minus 4. Okay students, so we write x minus 4y is equal to 48. So this is student our equation of directrix. Okay student. If we are taking this side, so this will be changed in negative. Okay, so equation of directrix is this. Now student, you know that our PS is equal to PM. Okay, so we apply this concept for find out the equation of parabola student. So PS is, this is PS and this is PM. So PS is, so when we are squaring this, PS is square and PM is square student, we write PS square is x minus 0 whole square plus y minus 5 whole square is equal to PM, which is x minus 4y 48 divided by under root a square plus b square, and this is minus 4 whole square. Okay student, now when we are going to expand this student, we are getting this is x square plus y square plus 25 minus 10y, which is equal to student, this part is also whole square student, so we can write 1 by 70 and x minus 4y minus 48 whole square. Okay student, now we are seeing that now we will expand this and get the equation of parabola. Okay student, so when we are expanding this, we are getting a student that after expansion and solving this, we are getting a student, our result is 16 x square and student plus y square plus 8xy plus 96x minus 554y and minus 1879 is equal to 0. This is student required equation of parabola. When we will expand this and this and multiply 16x square, after solving we get this result. I hope you understand students. Let's see once again. This is our parabola and this is our focus and this is vertex, and we have to find the equation of this parabola. Okay student, so we are seeing that this is our directrix and this vertex is the midpoint of the directrix and focus. So we will find, let's suppose that the coordinate of this r is x1 y1, so we write 2 is x1 plus 0 by 2 and minus 3 is y1 plus 5 by 2, and getting x1 is 4, y1 is minus 11. Okay, so coordinate of r is student 4 minus 11. Now we are going to find out, our target is to find out the equation of this directrix. Okay student, okay, so for find out the equation of the directrix, first of all we have find the slope of this line and we will find the slope of the perpendicular line. Okay, so slope of AS is y2 minus y1 upon x2 minus x1, which is minus 4. Slope of MR is minus 1 by minus 4, so this is equal to 1 by 4. the equation of line this MR, which is passing through the point 4 minus 11 and having slope 1 by 4 is y minus y1 and x minus x1. Okay, solving we are getting x minus 4y minus 48 is equal to 0. This is the required equation of this Directrix. And you know, student, that our PS is equal to PM, so we are writing PS square PM square. So PM, okay student. Now we are applying this concept and we write x minus 0 whole square plus y minus 5 whole square, and this is our PM, which is perpendicular distance. Okay, so we write x minus 4y minus 4 that under 1 square plus minus 4 whole square, student. Okay, now when we expand this a square plus b square minus 2ab, and when we apply the formula of here a plus b plus c whole square, a square plus b square plus 2ab plus 2bc plus 2ca, and in denominator the root will be removed, it will be 17. And when we will do cross multiplication and further solve it, we get the result this. Okay student, I hope you understand. Now we take another question, student. So next question is, student, find the equation of parabola whose vertex is 2, 1 and vertex is 2, 1 and directrix is x is equal to y plus 1. Okay student, so this is minus 1. Okay, so we have to find the equation of parabola. Okay, so this is our vertex whose coordinate is given to us 2, 1. This is point P whose coordinate is xy, and this is our S, which is we have to find out this is x1 y1 and here the directrix. Okay, so this is PM, which is x minus y plus 1 is equal to 0. Okay student, now student, this is our R. So for find out the equation of parabola, we have to find out first the coordinate of this x1 y1. Okay student, so find out the coordinate of this x1 y1, we have to know the coordinate of this R. Okay, so for find out the coordinate of R, you know, we know the equation of this line, so we have to find the equation of this line R S. Okay student, so we write the equation of line perpendicular to the x minus y plus 1 is 0 is x minus y plus, sorry, this is x minus y plus 1 plus lambda is equal to 0 student. Okay, now student, we are seeing that sorry, this is x plus y plus lambda is equal to 0. Okay student, now okay student, so this is the equation of perpendicular line to this, and this line is passing through, this is passing through 2, 1, so we write 1 plus 2 plus lambda is 0. this implies lambda is minus 3. So equation of perpendicular line is x plus y minus 3 is equal to 0. Okay, student. Now, student, we will find the intersection of this line and this line. Okay, so we will find the coordinate of this r. So solving equation first and second, we get the coordinate of r. Okay, so our x minus y is equal to minus 1, x plus y is equal to minus 3. We are getting that 2x is minus 4, so x is minus 2 and y is equal to x plus 1. So x is minus 2 plus 1, y is minus 1. Okay, so the coordinate of r is, minus 2 minus 1. Okay, so coordinate of r is this. So a is equal to now, student, you know that this a vertex a is the midpoint of r and s. Okay, student, so we apply the midpoint formula and get the coordinate of this focus. Okay, so we write 2 is equal to minus 2 plus x1 by 2. So this is 4 plus 2 is x1. So this implies x1 is 6. Okay, now 1 is minus 1 plus y1 by 2. So we write 2 plus 1 is y1. This implies y1 is 3. Okay, student. So the coordinate of focus is 6, 3. Okay, student. So from here we have calculated the coordinate of this r is, sorry student, here is a mistake. Here is lambda is minus 3. Okay, so when we send this right hand side, it will be what? 3, and this 2x is plus 2 and x is equal to 1 and x is 1, so y is 2. So the coordinate of r is 1 comma 2. Now the midpoint is 2 is 1 plus 2, so this is 1 plus x1 by 2. So this is 24 minus 1, this is equal to 3 and this is 2. So we write this is 2 is equal to 2, so this will be 0. So the coordinate will be 3 comma 0. Okay, so the coordinate is 3 comma 0. Now student, we can now find the equation of parabola. So ps square is pm square. So we write x and this is 3 comma 0. So x minus 3 square plus y square is pm, which is x minus y plus 1 by under root 1 square plus minus 1 square whole square. So x square plus 9 minus 6x plus y square is, this is 1 by 2 and this is, we write x square plus y square plus 1 and minus 2xy minus 2y plus 2x. Okay, now student, this when we will solve it, we get our result. Okay student, I hope you understand. Now do the cross multiplication. Here we write 2x square 2y square minus 12x plus 18 is equal to x square plus y square minus 2xy minus 2y plus 2x plus 1. Now solving student this, we write x square plus y square and this is plus 2xy and minus 14x and plus 2y, and this is plus 17 is equal to 0. Okay, student. So this is our required result. Okay, student. I hope you understand, friends. This is our question where we have to find out the coordinate of this focus first. So for find out the coordinate of this focus, first we find the equation of this RS. Okay. So the line perpendicular to this directrix is bx minus ay is equal to lambda. So we write x plus y plus lambda is equal to 0, and this is 2, 1. Okay. So lambda is minus 3. So equation of perpendicular line is x plus y minus 3 is 0. Now solving this and this, we are getting coordinate 1, 2. Now applying the midpoint formula by midpoint. So we find the coordinate of x1 and y1, which is 3, 0. Now this PS is equal to PM, student. So we write what? X minus 3 whole square y square, and this is a square plus b square plus c square minus 2ab 2ab plus 2bc plus 2ca, and solving this we get our result. I hope you understand, friends. Thank you.